All right, everybody, welcome back to another Ask a Dev Unreal Engine live tutorial. We do these once a week usually, and often we will sprinkle in additional videos and training based on community requests. Today we are talking about your first animation blueprint. So we're going to be talking all about animation blueprints, what they are, taking a step back, looking at how they play into building our character and setting up our experience or engine or whatever. My name's Kevin. I currently work as a senior principal tech artist at Riot Games. I work in R&D. I can do a lot of really cool stuff, but I learn a ton through you all in the community. So, off the rails, welcome to the stream. It's good to see you again. Everybody who's been part of the community, speaking of community, you guys have been awesome. Join us on Discord. We also have the Patreon, but a lot of people, throwing in, helping each other, asking questions, answering questions. It's been a lot of fun to see that get rolling. So, with that. The way this generally goes is I'm going to kind of go through this tutorial, we'll walk through it. If you have questions specifically about what I'm doing, I will try to answer those as we go. If you have more general Unreal questions, I'm happy to try to answer those at the end, depending on how we're doing time-wise. Lately, we've been running long on these, so we'll see how today goes. If we don't get to the general questions, we'll try to either make a new video or we can throw those in our community questions board. So with that, let's go ahead and get started. So, I kind of skipped the setup on this one just for time's sake. Literally all this is it's a fresh, brand new third-person blueprint. And if you open it up and you just press play, you will see we have our character running around and animating. And this is what we're talking about today. Now, typically speaking, when you check out any of the tutorials on an Anim Blueprint, they'll hop right in and start making an animation blueprint. We're going to do this a little bit differently. I want to take a step back and take a look at how the animation blueprint interacts with our pawn, why we like it, and why we need it. So to do that, let's make a couple of changes here. So what we're going to do is underneath our third-person blueprints is our BP third-person character. And what I want to help connect the dots or join the dots, depending on where you're from, is how this ties in, how the animation blueprint ties into what it is we're doing. Evgeny, welcome. So here's what we're doing. We have our third-person character, and on our third-person character, if you look under the class defaults for the BP third-person character over details, you'll see this thing that says Use Animation Blueprint, and right now it's set to the Anim Blueprint for Quinn. I am going to disconnect this, completely disconnected. And the reason we're disconnecting this is I want you to understand the connection between the animation blueprint and what your character is doing. So if we did not have an animation blueprint, our character would walk around like so. Basically, this is often called a T-pose, but basically this is the default pose of our character. Now, specifically, what I want you to notice is I am going to, I press the back tick and that brings up a menu here. It's a little bit more kind of along the debugging thing, but I can type in here, show collision. If you're not following along with the show collision part of it, don't worry. But what I want you to see is when I show collision, you'll notice that there's this round capsule around our character. And the piece and the separation that I want you to understand and think about when we think about animation blueprints is when we control our character and we're walking around, we're not controlling our character through animation. What we're actually controlling is this capsule. And then what we want to do is as we move the capsule, we want to try to sync our character's animation with the capsule movement. So it looks like our character is actually animating, but really what's happening is this crazy magic dance where we're actually moving the capsule and then we're trying to tie the visuals to the capsule movement to make it all look seamless. This is where the animation blueprint comes in, to try to tie those visuals together. For example, let me get our chats back up just so I can make sure that we are good there. Okay, so, and you can also see, so as I'm moving, the capsule is just sliding around. And if I jump, you'll notice the capsule also jumps. So jump is not happening because I'm telling the character to animate and jump. What jump is doing is it's moving the capsule up and down. And then I, as the developer, have to step in and sync the jump animation to line up with the actual capsule movement. And that's the tricky dance that we're doing when we're working with animation blueprints. So let's take a look at how that works from the bottom up by creating our own animation blueprint. Now, I'm going to make a couple other changes here. I am going to, in our third person character, I'm going to go ahead and change this to Manny, simple. And you'll see that the only change that has is that's just the change in the visual. Okay? So now we just have the masculine version of our character, and then we're going to go back, and what we're going to do is we're going to create our first animation blueprint. And as we do that, there are generally two different ways to do that. What you can do is you can, in your content browser, underneath your characters for our mannequins, we can choose the meshes. The animation blueprint is tied to the mesh and the skeleton, so that's how you know where to look. And you can right click on any skeletal mesh, and under the create menu that pops up, you'll notice there's an Anim blueprint here. So if you do that, it will create an Anim blueprint for the Manny skeletal mesh. You can also right click and do a new animation blueprint here, but then you will have to pick the right skeleton. That method works until you fast forward and your game has 500 characters in it. Then this is a little bit more roundabout to me personally. So I like to right click on my character and I'm just going to choose create and a blueprint. And we are going to call this ABP for Anim Blueprint. And this is going to be intro Manny. All right, now let's open this up. Okay. Here's our first animation blueprint. Something to understand depending on how it opens for you is kind of what all this stuff adds up to be. So in general, on the left side, this is our preview window. In the middle, we have two graphs. We have our event graph and our Anim graph. They're both special for the case of animation blueprints. And then we have all of our usual details. One of the things that is worth pointing out is it is technically possible, I think. I'm gonna kick myself for trying to do this if it doesn't work, but let's just see. I just want to see if we take our mesh, I believe we can play an animation on this mesh. Yes, so we can play an animation on our mesh in our normal character blueprint. So let me back up. So the trick to making our character look like it's moving is to line the animation up with the capsule movement. We could technically play animation and montages and all those things within our character blueprint, but then you get into this nightmare of, when the character's running, it's playing one thing, transitioning between states, bone blending, all these kinds of fancy stuff that the animation blueprint is specifically made to help us with. But you could technically play a looping animation on your character even without an animation blueprint. So that's just one thing to know. But the reason we like the animation blueprint and the reason it's special is because it's hyper focused on just the animation aspect of our character. So we do have an event graph, we do have an Anim graph, and we have the normal details. Generally, the way to think about this is your event graph is all about setting up all of the variables and values that your Anim graph uses to control animation and transitions. That's going to become a little bit more clear in a minute, but for now, just understand that this is generally all about getting all the information and data you need to drive the actual animation blueprint. Hey Westons, welcome to the stream. Sorry, it is really hot and dry here today, so I want to make sure that we're good to go. All right, so that's what the event graph is. We're going to be using that in a little bit. So let's hop into our Anim graph and show you under the basics what this does. Now, I do want to call out one thing, because this mistake has bitten us in previous tutorials. You'll notice this big yellow warning that says the post-process Anim blueprint for Manny is running, disable or whatever. That is a whole other thing. We're going to get into that when we start talking about skeleton compatibilities and post-process Anim blueprints. But for now, I'm just going to disable that so that in my preview, I'm seeing only what the animation blueprint is showing me. Okay, so we have our event graph. That's all about the variables and the data that drives the decisions that we make in the Anim graph, loosely speaking. Then we have our Anim graph. And you'll notice when you open your Anim graph, you only have one thing, an output pose. Everything that happens gets basically consolidated down into this final output pose, and this is what will play on your character. So for example, if I right click in here and I want to just play an animation, I'm going to make this the simplest animation graph possible, and let's just play the animation for walk forward. So I right click, I chose, and this is why I'm using the third person character start project, because there's a couple of animations for us to work with here. So I just right clicked and I typed the words play, and then I happen to know that the name of this animation is underbar, and it's, I don't know, mannequin movement, master movement, I'm not sure what that is, but anyways, there's a bunch of these. You can also get to them by just looking in the sequences in the graph, but anyways, we have our walk forward. If I simply connect this into our pose, what this graph does is it takes the animation sequence and it plays all of those values on our character's skeleton. So if we compile this, you'll notice that our character is now walking. That is all this character can do in the animation blueprint. And if we now go into our game and we press play, oh, we need to connect our blueprint. We do need to do that. Let's go back and do that. So we have our new Anim Blueprint intro Manny. We need to set that to be the animation blueprint that is being used by our character. So on our third person character, on the mesh, when we choose underneath animation, use animation blueprint, let's just type, or let's use this intro, animation blueprint intro Manny, compile that. And now when we play, you'll notice that our character walks. This is all our character does, but it's still pretty cool. So we've already got our character walking, and if we bring back our capsules, you can see the character is just walking within the capsule. So we've started our journey of trying to do this magic dance of making our animation sync with where our character capsule is going. Hey Shadow TJ, welcome to the stream. I see you joined us from the YouTube side this time. Okay, but you'll notice that as I'm walking, this looks pretty good as I'm walking at a certain pace and velocity. That's pretty good. I'm happy with that. If I jump, nothing. Like the character moonwalks basically. So this is where we start getting into some of the tricks within our animation blueprint. If we were to connect a different animation in here, and if we right click and I just choose play, and I'm just going to do underbar so you can see how this works. If I connect jump in here and I compile this, you'll notice that our character jumps. So if I were to go press play in our game, our character jumps everywhere. As I'm walking around the screen, character's jumping. Now the interesting thing is, even though the character's jumping, this is cool, let me show you the capsule. Even though our character's animation is jumping, the capsule is not. See how the capsule is sitting on the floor? It's not moving. If I time my jump 3 die, welcome. If I time my jump, you'll see that I can almost make it look like my character is actually jumping correctly. But really, again, what I'm doing is I'm controlling the capsule and the animation is trying to sync with that. Okay, so we have a couple of animations. Now, what is kind of our next step in these decision trees? So let's see here. Weston, do you have any opinions in third-party tools like iClone or Cascador with respect to animation? No. Okay, so Weston's question is a good one. These animations all are generally, there's many ways to author these animations. And I'm happy to answer this. It's kind of part of the tutorial. Where did this jump come from? Somebody animated this jump. And the way that this jump was animated, there's many different ways this jump could have been animated. It could have been done in something like Maya. It could have been animated in Blender by a character animator. It could have been motion captured. They had a big motion capture stage, a bunch of people running around in suits, and they basically record their motions and they bring those into Unreal. Those are a few of them. Another one is there's a bunch of new tools out like Cascador and others that are AI versions / help you animate faster. The general deal is it's still just about making the animation. And then of course you can also author these animations in Unreal. So a quick little sidebar as to where these animations even came from. We just dropped a video about the character pipeline that talks a little bit about that as well. Okay, so we have our forward walk and our jump, but how do we make decisions about which one of these play? Well, this is kind of where we start getting into some of the specialness of the Anim Graph. All right, one of the things that you'll hear people talk about a lot is you'll see people talk about pose caches, and state machines. So effectively, wouldn't it be cool if, and we're going to keep this, let's keep this simple. I'm going to drop in another animation just so you can see it. Let's do play MM idle. All right, this is the idle. I'm going to plug this in and press compile and you'll be able to see the difference. Character's just standing here. This is great. Wouldn't it be cool if, as the character started moving, the character started to actually walk instead? And how do we control that in our animation blueprint? Well, there's a couple of tricks to that. So some of those tricks are, we need some variables and data to help drive that. We need to know if the character is moving. And this is where our event graph comes in. Okay, so let me do a couple things here. I'm gonna move this off to the side. Okay, and what we're going to do is we're going to go back to our event graph, and there's two main events that are worth talking about, at least in the context of this tutorial. Generally speaking, just like other blueprints, there are, most of your actor blueprints have something called begin play. Your animation blueprint is special. It has something called initialize. Event blueprint initialize animation. So a lot of times, one of the things that you'll see people doing is they will take, and when the animation blueprints first get started, they will create some variables to store handles, basically information about the character that this blueprint is running on, and the movement component, because those are two of the main things that we're going to use to set variables as our game ticks. And remember, tick is basically each frame. All right, so when we first start, we are going to get our owning pawn, I believe. Yeah, let's just get our, we'll do this just like they do in the tutorial. So we'll get our owning actor, and what I'm going to do is I'm going to cast this to a character. Cast to character. And the reason I'm doing this, if you're not familiar with casting, there's a whole other video about casting, but the general gist of this is we take our owning actor. There's a chance this animation blueprint could be on a dog, it could be on a biped, it could be on a box. There's lots of different things this thing could be on. So when we get our owning actor for this Anim blueprint, we want to check to see, is it actually a character? This casting basically says, can this be a character? And if the answer is yes, keep going. If not, don't. It's kind of like that whole, if you remember, a square can be a rhombus, but a rhombus can't be a square thing from school. Let me just check a thing. Yeah, Cascadeur is AI based. Unreal facial rig. Cool. All right. So we're basically casting to our character, and we are going to store this. I'm going to promote this to a variable. I'm not going to call this as character. I'm just going to call this character. And then the reason we did that is because I want to get one more thing. Let's get the movement component. Get the movement. Drag off. Let's just try character movement. Here we go. So we're going to get our character movement component, and I'm also going to promote this to a variable. And the reason I'm doing that is because almost everything I need to know to drive this Anim graph, like is the character walking, are they jumping, how fast are they moving, all those things, that's part of the movement component. So now that I have that stored, this happens one time, this initialize animation. When the animation blueprint gets kicked off, this happened, it's going to store my character and my character movement. Now, as the animation blueprint is ticking along through our experience, what we can do is we can get information. So one of the things that would be cool to get would be how fast our character is moving. And we can get that now that we have a handle to it from our character movement. So from here, what we're going to do, let me just delete this because this is just in the way. What we're going to do is I'm going to get the acceleration. Nah, I'm not going to do that. Let's just get the velocity. Let's just start with velocity. That'll be easier. Let's just get our velocity right here. And I am going to take this information, and what I'm going to do is I'm going to get basically the length of that. So again, referencing back to another video we did, it's great that we did a bunch of these videos now. The velocity it is a vector, and a vector has direction and magnitude, so we know which way the character is moving and we know how fast they're moving. So one of the things we can do with the velocity vector is we can get the length of it. Now there's some interesting thing. If we just got the length of this vector, we remember down and up are also directional, and they also have velocity. So if we only got the length of the vector, if our character was falling, they might think that they had ground speed, because we're specifically going to make a variable called ground speed out of this. So the reason I'm not choosing vector length is because I don't want jump, for example, or fall to affect my actual ground speed. So that's why I'm going to get this vector length xy. This vector length xy limits the length calculation to be within the plane of the ground plane, because remember, the ground plane in Unreal Engine is xy. Z is up in Unreal Engine. A lot of you that are coming from Mayan 3D modeling packages, don't forget, Y is not up in Unreal, Z is up in Unreal. So this xy gives us a value that is effectively the ground speed, and I'm going to promote this to a variable. And the variable I'm going to call this, we'll call this ground speed. Okay, and we'll connect in our update. All right, so that is it. We now have a variable that we can use to make decisions on, for example. Okay, another one that we might want to take a look at is falling. So let's do that. From our character movement, I'm going to get it again, and I am just going to get falling. Oops, I clicked wrong. This is just a part of the variables that come with character movement. The reason I want to know if I'm falling is because this is true if our character is not on the ground. So I'm just going to take this and I'm going to promote this to a variable, and we are going to name the variable exactly what it came from. In this case, this is going to be B is falling. Okay, so now that we have two variables, let's see if we can make some decisions based on this in our animation graph. And let me show you how that might work. Okay, so we have a problem. What we want to do is we want to decide if we should be walking, idling, or jumping. But we can't play all three of these animations at the same time. There's only one skeleton. So we need a way to turn off these animations or turn them on based on the values that are being set, is falling, ground speed, etc. So a way to do that is, for example, we could do, let's see here. Alpha, is that one I want? Blend, layered blend. Let's try layered blend. Okay, so this is a way of combining two animations. So the two animations that I'm going to combine, in this case, this layered blend is going to be our walk and our jump. All right, and if I plug this in to our output pose and I compile, you'll notice that the character is walking. If I change my blend to 0 and I compile, oh, hold on, layer setup, I missed something. I think we need this to be root and 100 maybe. Compile. This is not the best way to do this, y'all. Okay, we're gonna cut bait on this and try it a different way. Ignore layered blend for bone. We'll come back to that. Basically, the way layered blend per bone works is when you put in two animations, you specify which bones have which weighting so you can split it up. But I think that's a little bit too much. So let's just go into the state machine where we can control this one-to-one. So we're going to stick with whole animations for right now. So what does that mean? I'm going to right click here and I'm going to type state machine. Oops. State machine. Okay. All right, what is a state machine? So I'm going to plug my state machine into our output graph. And what's going to happen, I'm going to get rid of these plain animations. And what we're going to do is inside the state machine, we're going to use the state machine to decide which animations we're playing. So all this still applies. In fact, if we compile, our character's not moving now. If we go into our state machine, how does this work? This is the next big thing that you'll see a lot of these tutorials doing. When you come into a state machine, you basically, as you go into it, what you're going to do is you're going to create different states that your character is in. For example, idle versus jumping. So let's do walking jump first. Just to continue with our example. So let's add a state and we're going to call this walk. This is the walk state. And if I go into the walk state by double clicking on it, I am simply going to play the animation I was playing before. And that's going to be the walk. Here's our walk forward. I'm going to plug this in. So when I do that, when I compile, you'll notice our character starts walking. Up here at the top, where we are, you can see this is our kind of like tree down into where we are. So we are inside the walk state. If I go back one, you'll see I'm inside this new state machine. If I go back one more, I'm in my Anim Graph. I'm going to call this state machine, let's call this locomotion, for example. Locomotion. All right, and right now, our locomotion state machine only does one thing. It only does walk. How do we make it decide between walk and jump? So double click on our locomotion. Here's our entry. This is where we start. We go straight into walk. Well, how do we get from walk to jump? Well, what we can do is we can drag off of walk and we can add a new state. And let's call this jump. Now, a lot of times these are named more appropriately for what they're doing, like jump, fall, run, walk, movement, locomotion, etc. But that's okay. Now, when I created that new state, hopefully you noticed something showed up. What showed up is what is called the transition rule. What happens is we have walk, And this is where we are right now. That's the state we're in. We've created a new state called jump. Let's go into jump and just connect our jump animation just to have it. So we're playing jump in here. And when I compile, you'll see no change to my character. It's still playing. If we go back one step to our locomotion, you'll notice that our walk is the only state that's active. We need to get to jump in order for jump to play. How do we control that? We control that with this transition rule. How do we control the transition rule? A transition rule is very basic. It is literally true or false. Can we enter this transition? Well, remember, we created a variable in our event graph called isFalling. isFalling is a little bit weird of a concept, but the general gist is this. If you're off the ground, you're falling. So if you've jumped, the minute you leave the ground, technically you are now falling. So there's going to be a couple other things that we'll layer onto this for jump, but in all intents and purposes, when we press jump, we're no longer on the ground, falling becomes true. Then what we want to happen in our state machine is we want to go from walk to jump. So let's do that. Let me double check for questions real quick. Okay, these are full animations. Do you use the Anim Graph for poses? Yes, depending on the context. So for example, idle can just be a pose. But technically, a lot of these, basically a pose, any single pose can just be a single frame that just loops, for example. Or poses for different parts of the game. Yeah, so there's a little bit of a confusing nomenclature here, because in animation the word pose usually refers to a single frame. So as a character animator, if you create a pose, or Madonna, you strike a pose, whatever you're doing, it is a single pose, a moment in time. But you got to remember the output pose that is output, like this basically here in our Anim graph. The reason this is called the output pose, and this makes sense, is because that is the output pose at that frame. It's at that frame. So you got to remember the result of the Anim graph is a pose at a single frame. So it all gets evaluated down to a frame by frame representation of the movement that we want on our character. So don't get confused by the idea of this output pose being a pose that's stuck in time. Two different things to think about as you're going through. Okay, Unreal has the variables is jumping, is crouching, is swimming. Why not use those? We could use those, but I think so. It's going to depend on how you set up your Anim graph and when to do that. So is jumping there, and there's a reason. So for example, is jumping would be true when you jump, but it also, depending on when that gets set to false. For example, let's take an example. This is a great question. When you press the space bar, is jumping is true. The minute you let go of the space bar, is jumping true still? No, you're falling now. So depending on the setup, sometimes is jumping is only true for a moment in time. And I want to specifically know that the character is off the ground. So the idea of is falling is less about jump and knowing that the character is off the ground. So let's continue with this. In our locomotion, we're walking. We want to do a transition to jump. In order to get this transition to happen, all we're going to do is connect our falling. Now, I know this seems counterintuitive. Remember, is falling is literally just whether or not we're off the ground. And the reason that's important is later, what happens is if you jump and you're in the air, you're going to, so for example, here's a great thing. Does everybody know the expression windmilling? When you jump and your character is in the air for too long and they start rolling down the windows or rolling up the windows, whatever it is, they're like, whoa, this motion, this loop, this fall loop, that's a falling loop. And we need to know that the character is in the air, but they're not jumping and they're falling, so that we can trigger this motion so that it looks like our character is unstable in the air if we want them to be. All right, so we've connected our transition, but you'll notice we're not using it yet. We're not using it yet because is falling right now is not true. Our character is not jumping. So here's what we're going to do. We're going to, where did that go? We're going to undock this. And I'm going to make this a little bit bigger. because just like normal blueprints, animation blueprints will let you see what's happening as you play. So if we go into our engine and we press play, you'll notice that our character in engine is playing. Okay? If I jump, theoretically, if we've done this right, live tutorials always go fun, right? If I jump, you should see the character jump. Did you see that? Okay. Couple things happen that are weird. So now our character is still jumping. Why is our character still jumping? Hold on. Let's one thing at a time here. Everybody, mostly me, slow down. All right. So first things first, when I press play, up here in our blueprint, so you can see it, let's make sure we choose our mannequin so that we're looking at the graph for that mannequin. And what I want you to note, and this is going to be fast, is as we jump, when we're walking, you can see we're still in the walk state. When I jump, watch how fast it goes to the jump state. Did you see that transition? Okay, so now we're in the jump state. And I'm just going to redock it so you can see it. So now we're in this jump state, but we're stuck here because we need a way to go back to walking. When do we go back to walking? We go back to walking when we're not falling, right? So in our state machine, what we can do is we can also create a transition back to walk. And when we do that, a transition rule shows up for us. That transition rule, just like the one to get to jump, needs to be set. What do we set that to? We are going to set that, if we double click on it, we are going to set that to not falling. How do we do that? Well, here's our falling. And if I drag off of this and I type in an exclamation point or not, I want the not Boolean. Booleans are fun. They can be true or false, and you can basically say do the opposite. What this is saying is, if we're not falling, we can enter this transition. All right, so what does that leave us? That leaves us with, when we come into, in our Anim Graph, the only thing in our Anim Graph is the locomotion state machine. If we look in the output of the locomotion state machine, at every single frame, that pose gets fed into the output pose that is displayed on our character mesh. Okay, if we go into the locomotion state machine, when we enter, the first place we go is to walk. That is our walk state. Inside of our walk state, we are playing the walk animation. We know we have a transition rule to go to jump. That transition rule is if it's falling, we'll go to jump. Okay? If we're in jump, we're playing the jump animation. However, if we no longer falling, in other words, if the movement component says we've hit the ground or any of those other things, we will transition back to walk. So let's go ahead and test that out. Now, we're walking. Pretty good. Okay. Now what happens if we jump? There we go. So we have transitioned back. So because we're not walking, or because the movement component updates to say we're no longer falling, we can use that to retransition back to our walk animation. Okay. Now, let's say, Evgeny, as far as whether or not we should call it is falling or off the ground or in the air, some of that is personal preference. I am specifically choosing these names because if you open the third person character starting point project, these are the names that you're going to see. And we're kind of rebuilding step by step various pieces of that to help give you a better understanding about how the animation blueprint works. So I don't want it to be too confusing if you go to open that and you're like, what are all these things? Okay. So let's see here. You can use the bool directly from movement component and then set your anim bool with it, or just you can use the boolean. Yes, you can. Okay, so 3Die has a very good point. Remember what I said earlier on, we use the event graph to store all of these variables. Okay? You do not have to do this. You do not have to take and store your character and create the character movement and set up your variables and store those off that you can then use. What you can do, to 3Die's point, is over here in this graph, rather than just plugging in is falling, you can, in this graph, you can get the owner. You can do anything that has I don't know if you can do half of it. You can't get the owner, but you can get the character movement component, which we've stored. And from here, you can just do is falling. And you can connect straight from this into your transition. But for various reasons, and so that I don't have all this all stored around, I'm storing the is falling variable. Also, once again, if you were to open the third person tutorial, and not the third person project, this is how you will see it connected up. Also, it's just faster. I mean, you're going to be using is falling in a lot of different states over time, and it's good to, it's nicer to just connect one thing than have to get the movement component and get is falling every time. But if there's something you're only using once, don't be afraid to drag in your character movement component and get all that information from there. Okay, so here we are. We have all of our transitions working right now, which is cool. Now, we kind of need, it would be kind of cool if we had another one. All right, and what I want to do is inside of our locomotion state machine, I want to change this. I want to add one more thing. It would be really cool if our character wasn't walking all the time. It'd be cool if we had idle. So let's drop in idle. Idle. Nope, not idle. We need a state. So we're going to add a state, and this state is going to be called idle. Now, inside of idle, what we're going to do, doesn't like me, is we are going to play idle. Play idle. Okay. We'll connect that up. We'll come back out. If we compile this, our character just idles. So just like we did before, we need a rule for when our character can transition to walk. Okay. So I'm going to drag from walk. I'm going to drag from idle to walk. It's going to create my transition and my transition rule. So what might be a good rule for whether or not our character can walk or not? Anybody? There's a wicked delay in the chat, so I may answer this question. I'm guessing a lot of you said if they're moving forward, if they have ground speed. So that's right, and we stored that variable. That variable is, we called it ground speed. So let's go back to our idle. And I'm going to close down some of these windows real quick just to clean this up because there's so many of these open. Okay, so in our idle, in our transition, I'm going to double click in our transition. And what I'm going to do is I'm going to get my ground speed. And let's just say my ground speed, let's just try this. Let's see if our ground speed is greater than, ground speeds are weird in Unreal because they're measured in newtons, I think. We do, Evgeny, and we're going to. Watch, we're going to get there in a second, but that is a great, what do they call that? Foreshadowing. So let's try a greater than 5. Okay, so if our ground speed is greater than 5, our character is going to transition to walk. Okay, if they're in walk, they are going to stay walking unless they jump. And if they jump, they're going to stay jumping unless they go back to not jumping, and we'll go back to walk. But right now we have no way to get back to idle. So what does this look like? Here's what this looks like right now. If we are start, you'll see we're idling. Perfect. If we move forward, our character starts walking. If we stop, they never stop walking. We need to connect our transition from walk back to idle. Okay? So what we're going to do in there is we're going to do the exact opposite. We're just going to get our ground speed. Okay? And if our ground speed is less than, now I want to be careful about this. Remember we said 5? If I choose less than, this is going to be super nuanced. If I choose less than 5, and I type this in, there is an edge case now. Okay? So if it's greater than 5, we start walking. If it's less than 5, we stop walking. But what happens if it's exactly 5? So you need to think about both sides of this. So I'm not going to use less than 5. I'm going to use less than or equal to 5. That way, I mean, the chances of it being exactly 5 is low, but let's just roll with this. So now, when we start, we're in idle. If we walk forward, we start walking. If we let go, we stop walking. Perfect. Yes, I would, how to get to the state of billionaire would be fun too, right? Okay, so we have our idle, we have our walk, but as Evgeny pointed out, what happens if we are in idle and we jump? So if we're in idle and I jump, there's no jump playing. That's because we need to be able to get from idle to jump as well. So we need a transition rule to jump. So we can just add that in. So we can make this crazy spaghetti mess. And you can start to see why organization is going to be important. So here we go. We have our jump now. And the way we get from idle to jump is literally the same thing as we were doing in our walk to jump, which was just is falling. Now, generally speaking, and I'm not sure if we're going to have time to get into it, but so let's just drag is falling into here and we'll compile and we'll save that. Okay, so now we have a way to get to jump. So here's the trick. We're in idle. If I jump, you'll notice the character jumps and they transition back. Now, how are they getting back to idle state? Well, if we take a look at our graph, what's happening is our character is going to jump. Once they get to jump, when they're not falling, they're transitioning back to walk. And when they're from walk, if the ground speed is less than 5, less than or equal to 5, my mistake, less than or equal to 5, it's going back to idle. So what is technically happening is we're going from idle to jump, and then from jump to walk to idle. So it is possible, as you get into this, you might see, like, this is where a lot of the magic and work comes into. You might see little glitches, right? If you saw a glitch from, like, when you think about how pristine frame by frame action needs to be to feel good, you're literally looking at every frame. If you saw a frame of a walk before you went to the idle or something, it may look like a little click. So what you can do is you can also go from jump to idle, for example. All right, and it's the exact same thing, but this one's a little bit trickier. Okay, so what we can do is we can say is falling. We can say not falling. Ooh, not. So if we're not falling, but we also want to make sure that our ground speed is less than or equal to 5. So let's do both. So here we're going to get our ground speed. And if this is less than or equal to 5, so that's the same. And this is also a great candidate. Let's do an and here. And I'll explain what I was going to say in a second. So if both of these are true, if we're not falling, in other words, we've hit the ground, and our ground speed is less than or equal to 5, we will go straight back to idle, hopefully. Now, there's a trick to this. All right, let me show you what the trick is. Because this transition is not falling, and this transition is not falling, which one does it take first? Well, in this particular case, you can actually change the priority of your transitions. So if you pick a transition, you look over here on the top right, you'll see I have a priority order. So in the case where we are jumping and I get to not falling and my ground speed is less than 5, less than or equal to 5, I want that to be the priority. I want to go straight to idle. I don't want to go back to walk and to idle. So what I can do is I can change the priority of this transition. And if you mouse over this, the priority order of the transition, if multiple transitions out of the state go true at the same time, the one with the smallest order will take precedent. So what I can do is I can change the priority of the transition from jump to walk to 2. So now what's going to happen is our character is no longer going to go through walk back to idle. They're just going to go straight from jump to idle if my ground speed is less than or equal to 5. Okay, so before we go ahead and take a look and I show you all of that working, I do want to point out one other thing. We are using this value 5 in a lot of places. Okay, it is worthwhile to make this already, in my opinion, even in this small demo that we've got going so far, it's worthwhile to make this a variable. So for me, I'm going to promote this to a ground speed threshold. Let's just call this ground speed threshold. Ground speed threshold. Let's compile that and default it to 5. And then what we can do is we can go back into this one. And rather than using 5, we'll just connect up our ground speed threshold. This way, I am not having to open up. Like you're starting to see that this can become just a rabbit hole, right? Like all kinds of things connected, all kinds of places. And so, so that I don't have to continually open up all of them, if I decide my threshold's wrong, I can change that in one place. This is why variables are awesome. So anywhere where I was using that value of 5, I've now set it to be that threshold, and we should be good to go. So now, if we compile and save this, if we go back to our engine, we should have our idle. If we walk forward and we stop, we should stop. If we jump and land, and we land. This is pretty cool. Now, one thing to take a look at as we move is if we fall off the edge. Did you see how that worked? The character still jumps. I didn't have to do anything. Why is that working? There were a bunch of questions around, why are we using is falling versus the jump and stuff. This is a great example. Technically speaking, I have not jumped when I walk off the edge. Okay? All that's happened is I've entered a falling state. The movement component has updated to this is falling. It updates that variable. So in this particular case, I can do things like have the ability to have a custom edge walk animation, for example. But in this case, this looks pretty good. Kind of just hops off. Now I could make it so they just walk off. And if they walk off, they would go straight into that falling animation, like in air type thing. You can add that in. But basically that's kind of what we get for free. So that is kind of a start for how we get into our state machines. Now, you can have more than one state machine and you can choose between what's happening, etc. So let's talk about this. So we have this locomotion state machine. Let's not go into multiple state machines. Let's talk about one more thing that you're going to notice. So just because it's worth talking about, anything that we put in after this is going to potentially alter the animation that's playing. What do I mean by that? The result of the locomotion is a pose on our joints. That pose will get put into the output pose. But if I do something that changes that pose, I'm effectively stomping everything that comes out of this state machine. What might that be like? For example, if I drag out of here, let's see, what can we do that would stomp this? Let's try our blend. Okay, so we have two poses. All right, this was actually the blend I was looking for earlier, not the layered bone. The layered bone is like the next level class. So, but for now, let's just, for argument's sake, let's do a play mm. Let's do our run forward, just so it's clear. If I plug all this in right now, our character has not changed. If I change this alpha to 1, the character will only run. The reason is what this node does is it basically is blending all of the joints in the skeleton between the two poses. So right now I've said I want this blend to be 100% the run. And now all of our animations are run. None of our jumps work, none of our state machine works, nothing. Because what's happening is this node, this blend node, that is happening after our locomotion state machine is stomping everything and putting it, basically updating the pose to be what it is. And if we put this to 0.5 and we compile this, you'll see that it's sort of running. And so what is actually happening now with this blend is it is half of our locomotion state machine and half of the run. So if we play this now, you'll see half of the animations that we have. So if we go forward, we see half. If we jump, we see half. It's kind of running and kind of jumping all at the same time. So what What I mean by that is there are lots of things you can basically, you're going to do lots of stuff to blend between. Like here's a great one. Let's say that you have your locomotion and that you have enemies in your scene and you want them to look at different things. What you could do is you could have head turn animations that are layered in that would override whatever the head is doing in your animation. And you could, another great one is aiming. If you have a weapon, you want your upper body to aim. When the player is aiming, they need to override whatever those animations are doing, so they're aiming at what they're doing. Another good one is slots. What in the world is a slot? Okay, so this will have no visual change on our animation. Okay, we're back to playing locomotion. What these slots are, and this is just a quick, because we're running out of time and I want to leave a little bit of time for questions, and we'll have to come back to blend spaces. I think we should do another class on, depending on what you all think, I think we can do a second animation blueprint class maybe next week, all about blend spaces and things like that. But at least so you understand what this is when we're playing our animations, we have our locomotion. It's our characters doing everything we want. But then let's say that you want to cast a spell and you have a custom animation that you want to play when you cast that spell. That custom animation is often played as part of an animation montage, for example. That montage is played in the default slot. So you can have multiple slots. And what happens is at the moment you start that spell, this default slot becomes active. It will override anything that's happening in locomotion, and it will play the spell. Another good example is an emote. Let's say that you've given your players the ability to emote. They press the emote key and that plays in the default slot. And maybe what we can do in the second or the follow-up classes to this one for animation blueprints is we can actually connect up our blend spaces, explain a little bit more about aliases in our state machines, as well as connecting up some of our animation montages. So let's see here. I think with that, for the first time in a very long time, we're going to wrap it at time. And I'm just gonna open up to some general questions to see if you all have any specific general questions that you want to go into. And also I need to catch up in some of, let me catch up in our chat a little bit here. Okay. If we have several playable characters, is it easiest to duplicate the Anim BP and update accordingly, or is there a macro function library tool to leverage? I think variables disappear when duplicated. Okay, Weston's good answer. Actually, Anim Blueprints have full inheritance as well. So what you can do is you can actually create, a child. So if you were to open the default third-person shooter, you will actually notice that the Anim Blueprint for Manny is the parent blueprint, and Quinn is actually a child of Manny, and then you override things as needed. Okay, so cool. We got that one. That's great. Lost track of time. Lucian, welcome to the stream. So Weston, so you can keep if you keep your scale up, but there's one thing to do. Okay, that's everybody helping out. Thank you all for helping out, answering questions in the chat. I super appreciate it. That's what I love about. That's what I love about how this community is rolling so far. The run is a little, yes, definitely a little old man alpha. Okay. I hadn't thought about that. I'll take a small party and agree the coach. Okay. Yeah, so the ALS plugin is the Advanced Locomotion System. That's an amazing reference. There's a lot of really cool stuff in there. And honestly, I feel like I personally loved the just the feel of the movement in that plugin. I think they stopped maintaining it after 4 something though. And finally, do we do live Q&A sessions on Discord? Yes-ish, we do. So what I mean by ish, I usually try to stream, or I'll hop on each night, and it's more just like we're all hanging out working on our projects and stuff. And occasionally, we'll throw out questions and do stuff like that. I do occasionally just hop in and answer questions and help people troubleshoot blueprints and stuff like that as well. So thank you all for being a part of this adventure. Hopefully today's live tutorial was edifying or adventurous for some of you, something new. I think I'll have a chat with the community in Discord and based on comments down below for this actual stream. I will go ahead and maybe set up a second half of animation blueprints for next week. If there's something, or if there's something else that's higher priority, we can always do that. As always, you all know how this works. If you dig what we're doing, help spread the word. Don't forget, we do have the Discord, we do have the Patreon, all that stuff is out there. And I will see you all on the next stream. Thanks for watching. Take it easy and have an awesome weekend, everybody.